the title will become clear eventually. Part of this, the notion of, it may be also that women stare at photons, but the title comes from a movie. I'll just put that up there for a second. If you've seen this movie, then you know what I'm talking about. This is referring to the movie The Men Who Stare at Goats, which is a story, fictionalized or semi-fictionalized story of the US government's interest in the use of psychic phenomena for military or intelligence purposes. So the staring at photons is an experiment that I'm talking about later, and I just like that image, so I put it up there. One of the problems that I face in the kind of research that I do, unlike what Jerry Pollack was talking about, if you're studying water, few people are going to get upset, except perhaps for other people who are studying water. If you're studying psychic phenomena, a lot of people become upset, at least within the scientific community, because when they hear what it is that I study, what they think of is that. In fact, most people think of that. They think of Hollywood and entertainment because that's basically all that we see, and we see it excessively. So part of my job then is to help people forget that that is certainly a part of popular culture, but that's not the kind of research that we do. Most of my research starts from paying attention to what people report, experiences. So here's an example of an email that I receive. I get hundreds of emails a week reporting various kinds of experiences. So here's one I got. I'm a normal 29-year-old man serving in the British Armed Forces. I have a way of foreseeing certain outcomes and therefore avoiding them. On my last tour of Afghanistan, I had to choose a route no less than 29 times, and each time I chose the safe route, whereas the patrol that took the other route came under contract from either small arms fire or improvised explosive device. You're probably going to say coincidence or lucky, as people usually do, but I know it's more than that. And so if we could either dismiss such reports, or in this case, the odds that he was correct, if it was really true that it was a binary decision, is 1/2 to the 29th, which is not coincidence. The question, the issue though, from a scientific perspective, is you never exactly know what's going on in an anecdote. Nevertheless, I pay attention to such things and take them seriously. Over the years, over the past 120 years or so, the kinds of experiences that people have reported have been put into a taxonomy with words that we all recognize, like telepathy. Some sort of information passes between people. Psychokinesis is somehow a person's intention is impressed out into the world. Clairvoyance is information from the world gets into your head somehow. And precognition or retrocognition is when the information coming from the world is slipped in time, either the future or the past. So that's the basic phenomena that we study. How do we explain this stuff? Well, there's roughly 5 different categories of explanations. The first one is coincidence, and these are very rough estimates based on anecdotes that people report and likely explanations. So about half of what people report are coincidence, or due to aspects of probability that people don't know about. Another bit is confabulation. This doesn't mean completely making it up, it means misremembering. You've remembered something slightly in a more positive way and it's confabulated. There's certainly some that is fraud. People take advantage of other people's belief in these kinds of phenomena. A good chunk of it is selective memory, but there's always a residue. There's something else. And so I'm interested in the something else. In our laboratory, we use the tools of neuroscience, psychophysiology, and physics primarily, and it's a mixture of all of those because as I said in the earlier slide, that what we're interested in is some form of anomalous information that's getting into your head, and maybe from somebody else's head or somewhere else, or it's expressed into the environment. And an easy way to think of the mechanism underneath it all is that there's information flowing, not force so much, but information. So these are the tools that are used to study information flow. This is a list of people who work in the lab or are consultants. And the range of expertise is everywhere from quantum theory to spiritual traditions and everything in between. We're basically involved in the study of consciousness and its capacities, and in order to study consciousness, you need to know everything. Well, so I don't know everything. What I try to do is find people who know things that I don't know and fill in the gaps. And as a team, then we try to figure out what we're doing. We're looking at two general theories. It's a way of thinking about how are we going to explain the phenomena that people talk about. So the first theory is the one that's mainstream neuroscience. This is a nice pamphlet you can download from the Society for Neuroscience, which basically gives you the overview of the neurosciences today. The Society for Neuroscience, if you went to their annual conference, you would be joined by 30,000 other people as compared to this conference. So you can see who's mainstream. Their theory basically is that you're nothing but a pack of neurons and you're a machine made of meat. That's more or less what this says, this pamphlet. The second theory is that consciousness is fundamental in some important way. It's not an epiphenomenon, and it's probably more important even than philosophers would imagine, more along the lines of what Eastern metaphysics tells us. So those are the two dramatically different theories that we're looking at, and we're trying to figure out which one makes more sense given these phenomena that we look at. We recently moved our lab, and this is looking at it from one direction. We have a shielded room. Here it's 2,800 pounds of solid steel. It's a Faraday cage, well grounded and all of that. We use it partially because it's a very convenient way of isolating somebody, so we know that the standard electromagnetic arguments can't be used to explain things like telepathy. It also turns out to be extremely quiet, but not so much acoustically as much as electromagnetically. And most people we're surrounded by electromagnetics all the time, and we don't go into environments where it's gone. From 10 kilohertz and above, E&M is gone. And people report typically that it feels incredibly quiet to them. And we try to remind them it's not actually the acoustic sense of quiet, it's an electromagnetic sense of quiet. So we think it helps people in doing the experiments that we do. So let's first look at telepathy as a class of experiments that we and our colleagues around the world have studied. I could go through the same exercise for each one of the major classes of phenomena, but due to the lack of time, I'm just going to focus on two. So the first one's telepathy. A standardized task that has come about over the years is called the Ganzfeld task. Ganzfeld is a German word meaning whole field. And the idea is that you take the person who will be the telepathic receiver, and you put them under a red light, and then you take a ping pong ball and you cut it in half. You put the ping pong ball over each eye, and you ask them to keep their eyes open. So what you're looking at now is just a uniform red field. That's where the Ganzfeld comes from. It's a uniform field, so the stimulus in your eye is red everywhere with your eyes open. You also then have them have headphones in which they're listening to white noise, and they're sitting in a comfy chair. And after 5 to 10 minutes of this, people begin to hallucinate. If you're in the process of falling asleep, you begin to get that hypnagogic state where you get very vivid imagery. That's what this thing evokes. And the reason is that you're awake, you're sitting up, your eyes are open, you can hear stuff, but there's no pattern of any type. And so the brain gets starved for some form of information, and you begin to generate it internally. So we want that. We want the person to be awake but be in a dreamy state. Meanwhile, we have a sender who's isolated at a distance. The sender is given something to think, and we want them to inject their thought, essentially, or their ideas into the other person's head. What I showed is something sending from sender to receiver, which is where those terms come from. But actually, what it's more like in practice is that something arises in this person's mind as a result of what we give to them to think about, and magically it shows up in the other person's thoughts. Nothing is sent. It's more like an entanglement or a correlation. So here's my assistant setting up a friend of ours in the Ganzfeld state with the ping pong balls. Here's an example where the sender might be given an image of an elephant, and that's what they're supposed to send to the receiver. The receiver, of course, has no idea what these images are. If it's done in a double-blind way, the experimenters also don't know what has been selected for the sender. So the sender is given a randomly selected image, has to send it over to the receiver, and if we're lucky, then the receiver will get something like animal and gray. The receivers are asked to both encourage them to stay awake by speaking aloud anything that comes to mind. So we call this mentation. It's the idea of taking thoughts, your cognition, and speaking it. You mentate it, and it's recorded on audio. After 20 minutes of the sending period, you take the person out of the Ganzfeld state. You play back the audio recording. And the reason why you do this is because when you're in that dreamy state, you actually are not very good at remembering what you said. It's a little bit like waking up from a dream. It fades very quickly. So this helps the receiver remember what they said. Here's an example of possible targets. And the targets includes a real one. In this case, like there's the real target, and they're decoys. And they're selected so that they're different from each other. And the task of the receiver is to select the correct one. And the chance of this design is 1 in 4. They would get it right by chance. So here's an example where we actually did it with Gail, who we were setting up in the lab in that picture. Those are the 4 pictures. This is what Gail said during the 20-minute sending period. She said something has a rough texture, tall, looking up high, like in an art gallery or in a museum, a Yosemite kind of image of a tall rock, monolithic, images of Mount Rushmore. So those are the impressions that she was getting from a person at a distance, actually on a different floor of a building about 40 meters away. And Gail's inside the electromagnetically shielded room. So based on that, if you were a judge, and those are the 4 possible things that could be sent, and that's what Gail said, what do you think that the sender was looking at? So let's see. So in fact, that was a target. The target was selected out of this pool randomly. In this case, it was me holding a die, and I threw the die until I got a number from 1 to 4, and the number came up that pointed to this target. So that was then the target that was sent. So in this case, Gail immediately chose that as the likely image, and so in this case, it was a hit. Otherwise, she would have gotten a miss. So these experiments last roughly 90 minutes from the beginning to the end, and you end up with a single data point with a probability of 1 in 4. So there's a lot of effort to get this one data point. Here's places that have done this kind of experiment from around the 1920s until today, lots of different universities. This is what you get in terms of the hit rate. Now remember that chance is 25% on this graph, that's over here. These are the results of individual experiments, 122 experiments from 20 laboratories around the world, doing over 4,600 sessions of the type that I just described. And now if you look at this not just from the point of view of each study, these are means and standard errors, but cumulatively, there's chance, there's a cumulative hit rate. Cumulative hit rate is about 32%, which lies there. Among other things, the odds against chance of being there as compared to chance expectation is 300 trillion quadrillion to 1. This has been discussed many times since 1994 in one of the top psychology journals called Psychological Bulletin. And the interesting thing is that since about the last maybe 1980s or so, the effect is stable. Now it's stable in the sense that the overall hit rate, it looks like it really, really is 32%. And it's stable because we have a lot of data before that. So we're narrowing in, and the more studies we do, we'll find that the mean and the standard errors will just keep, the mean will be stable and the standard errors will keep shrinking. So this is a little bit like what Rupert was mentioning before. We were measuring the gravitational constant. The telepathic constant in this experiment, at least, seems to be fluctuating and stabilizing around 32%. That means that roughly that in a game of 1 in 4, where you're trying to choose 1 in 4, that collapses into a game of 1 in 3, 25% to roughly 32, 33%. The information's coming from somewhere. The question is where? Oh, the other thing is, when you have odds of 300 trillion quadrillion to 1, what does that actually mean? It means that if telepathy did not exist, we'd have to run this same kind of experiment 300 trillion quadrillion times to get a result as good or better than we've observed. And so if you look at the age of the universe, it would take longer than the life of the universe to get these results by chance. That's one way of thinking about, is this really as good as it appears? Probably. In fact, it would take many, many, many universes of the length that we are now in order to get this result by chance. So we have a due diligence list to make sure we're not fooling ourselves, and we go through lots of alternative explanations for this, everything from sensory leakage and somehow information got from the sender to the receiver by ordinary means, to recording mistakes, variations in experimental quality, fraud, And the bottom one always in science, especially for a controversial topic, is replication, especially replication by skeptics. And by skeptics, I'm skeptical about it, but we're talking here about people who have professed publicly that they don't believe it, that kind of skeptic. So in 2005, we had two people, one from the University of Georgia and the other University of Notre Dame, who actually did this experiment. They expressed in the journal article that they did not believe that psychic abilities existed. Nevertheless, they went ahead and did experiments of the type I just described. They did 8 experiments and they had an overall statistically significant hit rate of 32%. They did not like this. So they wrote that this was precariously close to demonstrating humans do have psychic powers. They did one additional experiment based on a new design that had not been tested before that they thought should increase the effect based on their idea of how psychic phenomena work. It did not work. They got a significantly negative result, and then they used that one experiment to dismiss all the rest of it. So the other thing is that prominent skeptics, like this is the British skeptic Richard Wiseman, whose career has basically been to show how all of this is nonsense. He admitted recently, or a couple of years ago now, in a newspaper article that something interesting is happening in this experiment. He said, I think that these studies do meet the usual standards for a normal claim in science. And this is based largely on a meta-analysis. This is a repeatable effect that's been looked at over many decades, and the effect's not going away. The 32% doesn't sound like much compared to 25%, but these are almost all unselected college sophomores. So average people are showing this effect. If we do selected people, selected based on things like creativity, then you get double this effect, 50 to 60%. Nevertheless, with 4,000 sessions in the can, people like Richard Wiseman say that this would meet the standards for a usual claim for establishing the effect. However, he still doesn't believe in telepathy because it's an extraordinary claim. Well, of course, extraordinary is in the mind of the beholder, and it's driven almost entirely by what existing theories would predict. So existing theories do not well predict telepathy, in which case it remains extraordinary and will continue to remain extraordinary until a theory is developed that would explain this. So if what I just said is true, that telepathy looks like it exists, and this is in a conscious state, remember, that the receivers are conscious and when they're responding, it should also exist unconsciously, because we know that there's tight correlations between cognition and brain function, so you should be able to do the following experiment. You have a sender, you have a receiver, you isolate them, you have them think of each other, keep each other in mind. You do something like a flashing light stimulus for the sender, and you hope that the receiver's brain jumps in correlation. Now this is like as primitive as you can get, because there's no emotional content, there's no images, there's nothing. There's just looking for a correlation in brain activity. So here's an example of an experiment like this that we did in the lab. This is Jenny sitting in the shielded room, getting wired up. There's when it looks like when you close the door, it looks like a refrigerator. At a distance, we have Charlene that is looking. She's in a dark room, looking at a closed-circuit TV, and every so often, Jenny's face will show up on the screen, and then it'll go away. And so, from Charlene's point of view, she's also wired up her brain. We're going to look at a visual stimulus in her brain and a reminder to connect with Jenny. So both of them were looking at their EEG. Charlene gets an explicit stimulus and Jenny gets nothing. She's just sitting there in the dark room. So what do you get? Well, in Charlene's brain, you get a big jump. It takes about 300 milliseconds to rise and fall, and it's a very well understood visual evoked response. In Jenny's brain, you also get a jump. In fact, if you look at the correlation in these two graphs, you get a highly statistically significant correlation between the two. This is not just these two pairs of women, but there are 13 pairs of people in this particular experiment, and this is the average result overall. So it looks like you can basically manufacture a correlation between two people isolated at a distance. And of course, we checked it to make sure that this effect was not due to an electromagnetic pulse that had somehow gotten from the stimulus, the TV turning on, into the electromagnetically shielded room, and we could demonstrate that that wasn't the case. We've had colleagues do similar experiments. This is from one at the University of Edinburgh. The top is the brain in 100 millisecond chunks. 100 milliseconds, the light flashes there. There's a lot of activity in the brain about 200 milliseconds later, and then it relaxes. So this is in the senders. This is a 15 couples average brain activity, and this is in the receivers, about 30 meters away and also in a Faraday cage. So the one interesting thing here is the light flash occurs there, and yet the receiver's brains are already becoming activated about 100 milliseconds before the stimulus occurs. And this actually it looks strange at first, but because I've also done lots of experiments on presentiment, which is an unconscious form of precognition, we actually would expect that to occur as well. Because the phenomena that we're talking about are not tightly locked into space and time. What I've been talking about telepathy is a spatial separation. We also see separations in time. If the EEG studies are correct, then it should also show up in a functional MRI. And then you'd also be able to tell where in the brain the effect is showing up. So our colleagues at Bastyr University in Seattle did an experiment in a functional MRI. This is the MRI image of the receiver's brain when the distant sender is seeing either a flickering checkerboard pattern or a static checkerboard pattern. And when you're looking, if you're looking in the brain at a flickering checkerboard pattern, the visual cortex lights up. This is the brain of the receiver. The receiver is in the MRI, which, as you know, or you may know, it's very heavily shielded electromagnetically and magnetically, and it's incredibly noisy. So from a sensory isolation point of view, it's a great place for a receiver to be. They're not getting any ordinary leakage here. And yet, the brain of the receiver is lighting up in the visual cortex. That's this back side of the brain here, and statistically very significantly. So this was published in 2001. The guy who did the radiology on this initially thought it wouldn't work at all. So he was very surprised to see this, and he went ahead and replicated this a couple years later with the same couple, so this is one couple, and published it in 2005, and basically got the same result, that the visual cortex of the receiver is lighting up to a highly statistically significant degree. So there are 7 studies using a functional MRI looking at various places in the brain that are showing that you can see what's happening in the brain, and it makes sense from a physiological point of view that somehow people are connected both at the conscious level and at the brain level. These studies are, unlike some of the research in the psi research world, these are not all in specialty journals. They're in journals that you can find fairly easily, including places like Science and Nature, International Journal of Neuroscience, and so on, neuroscience letters. So you could find this without too much trouble. Most people don't bother to look for it. So does telepathy exist? If there was such a thing as a court of scientific opinion, where it was based on the evidence rather than based on television shows, I think you would get to the conclusion that there is converging, repeatable, controlled evidence that telepathy exists beyond a reasonable doubt. And I could show several other classes of data which are consistent with the idea of telepathy, again looking at unconscious physiological connections between people. Rupert had mentioned the feeling of being stared at, and there have been many, many studies looking at that, both conscious responses and unconscious. And that is a kind of telepathic connection. So we have lots of converging evidence suggesting that at least sometimes when people report a telepathic connection, that they're probably correct. What percentage? We don't know from anecdotes, but we know in principle that it's possible. Yeah, but good luck getting it peer reviewed. This, of course, is a chronic problem.